Everyone. Welcome to today's chemistry lesson. My name is Laura. I'm chemistry teacher. So today we are going to explore the key concept in the chemistry called valency or valence, just the valence. So first of all, this session is designed to be an interactive guide. Together we will learn what valence is, how to use it, and how to write chemical formulas. We will learn how to use quick cross method, and then we will do some practice, task, and homework preparation. Let's get started. So first, in our presentation, you can see combining capacity. What does it mean? Valence is a measure of an element's ability to combine with other atoms when forming chemical compounds. Atoms and molecules, like a human. Some human like being alone. Some human like being love being with many people. So, and they hold a hand. Some just with one person. Some of people with many of number of a large number. So, and the valence electron for holding, holding, we use valence electron. Not we, molecule, atoms use valence electron, which are the electron in the outermost shell of the atom. So, as you can see in the atomic diagram, here we should have atomic diagram, but we don't have because photo is not download. So, let's imagine just we have nucleus and have some shell and have outermost shell. In the outermost shell we have some electrons. That electrons in the outermost shell, in the last shell, help us to make connection between atoms. So why do atoms combine? Because of the octet rule. Atom always strive to have a stable outer shell with 8 electrons. That's the goal. So they do this by losing, gaining, or sharing electrons with others. For example, if you look at a periodic table, we can see noble gases. Noble gases already have a complete outer shell. This is why their valence is zero, meaning they are heavy and reactive, most of them unreactive. So, valence and periodic tense. Now, how do we find valency of an element using a periodic table? We have three main rules. Metals in a group, second, non-metals, and third, transition metals. In the first of all, metals, they tend to lose electron. They located in the group from 1 to 30, so their valence is simply equal to their group number. For example, sodium. Sodium is in the group 1. It valence have 1. Magnesium in the group 2, so it valence have 2. Now I just show you sodium. So now periodic table. Let's take a periodic table. Periodic table. Let's look. Let's watch. So well, here we see sodium in the first group and magnesium in the second group. They have same to the group electron number. And so next, uh, next about nonmetals. They want to gain the shared electron, so we calculate their valency by substituting the group number from 8. For example, oxygen in group 16. So the valence is 2. Why? Because we from the last we start our numbering from the last. First, second, third, null, 0, -1, and -2. Do you understand? This is non-metals. So, in the about third transition metal, the element in the middle of the table, and they can change their valence. For example, iron have 2 or 3 valence, and the copper have 1 or 2. Well, here you may see them. These atoms can change the valence number. So here valence number. And the next about crisscross method. How do we write chemical formulas? How? We don't know. We use crisscross method. Oh, I'm so sorry. I should open one. Where is? Let's. But where? Ah, here we can see it. So, to write the formula of binary compound, we swap to crisscross of the valency of the atom. They become the subscripts of the opposite atom. So let's start. Step 1. Now let's take an atom. For example, no, we can't. See, we should change the change the color. So hydrogen, for example, let's take the hydrogen. Oh, why? Hydrogen and oxygen. How we say before, hydrogen or oxygen have -2 valency, and the hydrogen have +1, and we write just one, just plus. So right there valency. That's our second step. We do that. And third step, swap the valence diagonal to become script. And the last, supply or reduce the subscription of the lower ratio of pulses. So here we use our crisscross method. That one is here, that one is here, and we took as we don't write the minus and plus, we write that just wait. As numbers, we take the as to O. But if we have, for example, carbon and oxygen, we do next. Carbon have 4 valency and oxygen 2. -2, we don't write it. We cross it and we should divide it. We can divide it. We can we can take smaller, less number. For example, we can divide it to 2. 2 we can divide to 2 also. And we take here 2 and there 1. So we take CO2. So that's our result. So next, next. Let me show you a real example of this method. That previous two examples was just for your understanding. Right? Now I show you a real example. So we want to find the formula of a compound made of aluminium and oxygen. We should use our ferric column. Second one, why we can't open it? We can open it. I'm a little bit sick. I'm so sorry. So we know that aluminium. We should change the color. Color. Can I use the white one? Yes, I can. So aluminium in the 13 group, and its valency was aluminium. Not was B. Is 3. And the oxygen, we know, equal to 2. So let's cross and take that one, that our result should be. How we do it? We write aluminium, we use valency of oxygen, write oxygen, so we use it, and it also we have used it, and only that one we don't take, don't believe. So same? Is it same? Yes, it's same. Oh, and the about next. Why? Why even? So that's some examples. If iron was 2, if iron was 3. Yeah, 2 examples, 2 situations. I know, I think that you understand my topic. So, mm, so. What if we have formula, but we need to find the valence? We should reverse cross method. We should use that, and we use it. That have used that before. I showed you how to make it, how to create it. So that's checkpoint question. It's your homework. Answer the question by your own, by make hard working, think a little bit, and that's all. I think practice task also. Another one, another one too. And so that's all. Goodbye. I'm very happy to see you in my lesson.